All right, so in this lesson, we're going to talk about arithmetic and geometric series. So I'm going to basically kind of scroll through the textbook, talk about, basically use that as my notes, and then I'll do some examples in Smart Notebook so you can see formulas and stuff being applied to problems. I'm going to move rather quick to keep the length of the video down because you're able to pause and you're also able to just watch it again. So here we go. All right. So first thing we need to understand is that we have a finite sequence versus a infinite sequence. So a finite sequence is a sequence of numbers that has a beginning and an end. All right, where an infinite sequence is a sequence of numbers that has a beginning but continues forever and ever with no end. So, like if I had a finite series, the difference between a sequence and a series is a sequence is just a pattern of numbers in a list, while a series is a summation of those numbers. So in a finite series, I could add these 5 numbers up and I would get a sum of 60. Okay. In an infinite series, I would take this and I would continue to add. So if I kept this pattern going, what is that eventually going to add up to? So we're going to get a couple formulas from this. The first is this sum of a finite arithmetic series. Okay, we can see here that the sum, which we say is S sub n, so the sum of n terms of a finite arithmetic series, a1 plus a2 plus a3, blah, 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 all the way up to the last term, is this. Okay, so that's S sub n equals n over 2 times a1 plus an. So I'm going to go over here. Well, not here. Let's go down here to the bottom. Come on, open up Smart Notebook. I said open up Smart Notebook. All right, so let me write the formula. So the sum of n terms is going to be n over 2 times a sub 1 plus a sub n. All right, what this means is the sum is the number of terms divided by 2 times the first term plus the last term. Okay, that's what that means in words. So let's apply it. All right, so if I go back, I'm going to take 6, 9, 12, 15, 18. All right, so go back to my pen. So 6, 9, 12, 15, 18. Now from the book, I know that this adds up to 60, okay, and I could just add these together on the calculator and get 60. The point isn't to get 60. The point is to show you how this formula works. So I see I have 1, 2, 3, I have 5 terms. So S sub 5 equals the 5 terms I have divided by 2 times the first term plus the last term. All right, so that's 2.5 times 24. Well, 2 times 24 is 48. Half of 24 is 12. So 48 and 12 gets me 60, which you can check on a calculator if you don't believe me. So I just want you to see this formula applied to a very simple example. All right. I'm going to go back to the book and see what we have on the next page. All right. What is the sum of the even integers from 2 to 100? So if I did the even integers, that would be 2, 4, 6, 8, 10, all the way up to 100. So let's look at that as an example. Let me add a page. All right, so if I had 2, 4, 6, 8, all the way up to 100, what would that add up to? Well, same formula. If I do the even numbers from 2 to 100, that's going to be 50 different numbers, because that's half of them. The odds would be the other half, equals n divided by 2 times the first term plus the last term. Okay? So that's 25 times 102. And I don't know what that is off the top of my head, so let me grab my calculator that you can't see and do 25 times 102. And I get 2,550. Okay, so if I added up 2 plus 4 plus 6 plus 8 plus 10 plus blah, 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 plus 100, I would get 2,550. Okay. All right. let's go back to the book, see what we got. All right. So we could look at this question right here about an application question. You can see it all worked out. A company pays a $10,000 bonus to salespeople at the end of their first 50 weeks if they make 10 sales in their first week and then improve their sales numbers by 2 each week thereafter. One salesperson qualified for the bonus with the minimum possible number of sales. How many sales did that salesperson make? So if they started at 10 and then they went up by 2 every week, that's the pattern would be 10, 12, 14, 16, 18, 20. And we see that they have 50 weeks, so N is 50. So you can see this is the sum would be S sub 50, and then 50 divided by 2, because it's the number of terms divided by 2, plus 10. Now, the only thing we're not given in here is this last term. So to find 108, you see what they've done here is they've taken the formula for an arithmetic sequence, and they've said, what's my 50th term? So they start at 10 plus, well, 50 terms down the line is actually counting 49 times 2, because that's your difference, 10, 12, 14, 16, 18. You're counting by 2s. So they found the last term to be 108, so they could use it down here. So sometimes you have to do a little bit of legwork before you're ready. Okay? Let's see if we run into anything else. All right, so you can also see how we write a series in summation notation. So, excuse me, sorry. What is summation notation for the series 7 plus 11 plus 15 plus blah, 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 blah? Okay? Well, we can come up with a formula that basically represents any one of these numbers if you plug in the term it is. So, for example, if I put 1 right here for the first term, 4 times 1 is 4 plus 3 is 7. Works. Okay? Second term, 4 times 2 is 8 plus 3 is 11. Third term, 4 times 12 is 15 plus 3 is 5, or 4 times 12, excuse me. Third term, 4 times 3 is 12 plus 3 is 15. Okay? So you see that this first one continues to work. All right. The only other thing we would have to check is to make sure that the 51st term actually works out to be 207. So I would plug in 51. That's going to get me 204. 204 plus 3 is 207. So this one actually does work out to be that one. Okay. All right, so that's summation notation. Basically, you have to come up with a pattern that represents, or you come up with an expression that represents your pattern. And then this is a Greek symbol sigma, and that stands for summation, or to add up terms. And then you have n equals 1, because you always have the first term, up to how many terms you have. So this is basically n for number of terms. Okay? Let's see what we got next. I think we're basically done with the explanation. All right. Okay, so if you were given it in series notation, how would you find the sum? Okay, so let's work through this example. So we're given this right here, summation n equals 1 to 70 of 5n plus 3. So it says here, since the formula is a linear function, the series is arithmetic. Okay, linear means that you have an exponent of 1 right here. If you had an exponent of 2 or 3, you might have geometric or something different. So, since the formula is linear, of the function of the series is arithmetic, so they suggest to find a sub 1. And then so find the first term, find the last term, and then use the formula we used before. So this is an example where you have to do some legwork. To fill in this formula, we have to know how many terms we have. We have to know n, which is 70, because that's what's on top of our summation. And then we have to know the first term and the last term. Well, the first term, I plug in 1. 5 times 1 is 5, plus 3 is 8. They have that right here. And then I'll find the last term by plugging in 70. 5 times 70 is 350. 350 plus 3 is 353. So now I'm ready to fill in the formula that we used earlier. Okay. Another example. This series is not arithmetic. However, you can evaluate by adding the terms. So this is not an arithmetic sequence, which means I cannot use this formula right here. Okay. I cannot use this summation formula. But what I can do is I can actually just work it out. So plug in 1, see what you get. Plug in 2, see what you get. Plug in 3, see what you get. Plug in 4, see what you get, etc., etc., etc. And then once I know all those answers, I can add those together and I get 91. So sometimes a strategy is to actually do it by hand. For example, this example right here, A, works like this example up here. I should be able to do that one just fine. this example right here is not linear, so I would actually have to plug in 1, plug in 2, plug in 3, and plug in 4. This example right here is not linear, so I'd actually have to plug in 1, well, let's see, -1. You're just going to get a bunch of 1s and -1s. So that actually may add to 0, because 0 is going to get you 1, 1 is going to get you -1, 2 is going to get you 1. So this probably adds to 0, which is an interesting example to look at. But you're just adding a bunch of 1s and -1s. Okay. So for example, I'm going to do this right here. So summation of n equals 1 to 40 of 3n minus 8. So summation of n equals 1 to 40 of 3n minus 8. And I'm going to go back and double check that I got that correct. And I did. Okay. So I need the first term, and I need the last term. That's the 40. I need the 40th term. So to get the first term, I'm going to plug in 1. Plug in the last one. Okay. Now I'm ready to add them up. Oh gosh. 2,140 would be what that adds up to. Okay. So you've seen this formula used 3 separate times. Hopefully you've seen the pattern and you know what you need to do to fill it in. Okay. Now let's go to, I think we get to the assignment next. Yeah, so you have some practice questions if you want. So, okay, let me just run through some directions real quick, okay, just so you kind of see. All right, so find the sum. Well, these you can just add together, okay? 2 plus 4 plus 6 plus 8, you can do that in a calculator, whatever you want to do. Here, you can use the formula. So 1, 2, 3, so 5, 6, 7, 8, 9, 10, 11. So 5, 6, 7, 8, 9, 10, 11. So that's 7 terms. So I would say like S sub 7 equals 7 divided by 2 times 5 plus 11. Okay. To write it in summation notation is a little bit more difficult because you have to come up with that pattern. Okay. Now, if it's linear, it's not terrible. Okay. But you do have to come up with a pattern before you write it like this. And then you can find the sum of each finite series if it's not exponential. So 21, 22, and 23, you can use the formula. 26, you can use the formula. 25, you can't because you have an exponent. And 24, you can't because you have an exponent. So those actually have to be done by hand. All right. Going over here. If it's finite or infinite, finite has an end, infinite doesn't. So here, comma, dot, dot, dot means it doesn't have an end, so it is infinite. Here, plus 25, it stops. Finite. Okay, it's that simple. All right, now let's try to talk geometric. All right, geometric series. All right, so here's the sum of a finite geometric series. So S sub n equals the first term times 1 minus the ratio to the nth term, or the n, over 1 minus r. Okay, so what is the sum of this geometric series? So let's look at this example. All right, it's a finite geometric series. Let's see what this title said back here. Yeah, so we should see them use this formula. Okay. All right, the first term is 3. The common ratio is 6 divided by 3, which is 2. Yeah, so what they're doing here is they're just checking by dividing. 6 divided by 3, 12 divided by 6, 24 divided by 12. You consistently get 2. So a sub n equals a sub 1 times r to the n. Use the explicit formula. So we need to know how many terms there are. So what they're doing is they're setting this formula, they're setting this last term equal to the formula because we have to figure out n. So divide by 3 and you get 1,024. And then 1,024 is 2 to the 10th. So that's 2 to an exponent. So n minus 1 has to be 10. So n minus 1 has to be 2 to the 10th. Let me show you what I mean by that. If I have the expression okay, I'm going to re-express this as 2 to some power, which the textbook told me that's 2 to the 10th. Okay, so you see that I have the same base. What I have to do now is I have to just see that these exponents have to be equal. So I'm going to add 1. So I have 11 terms. Nope, I didn't add 1. Okay, I have 11 terms. So we'll go back here and see that they also have 11 terms. So they see that n is 11. So now they pull the formula from the last page. First term is 3. It's right there. 1 minus 2, your ratio is 2 because you're doubling every time. We had to figure out that n was 11. We had to figure out how many terms we had. And then over 1 minus 2. Then you just work this out algebraically by doing exponents first, then parentheses, then numerator, denominator, and then divide. So you do all that work, and you get 6,141. Okay? All right. Let's look at what this might look like in a summation type thing. The first term, oh gosh, why are you scrolling? Okay. Oh, goodness gracious. All right. The first term is a sub 1, so they plug in 1. Oh, the first term is a sub 1, so they plug in the first number. You have to be careful. A lot of times with a sub 1, we assume we're going to plug in 1. A sub 1 means first term. So if I look here at this summation, n starts at 0. So I plug in 0 to get the first term. So 4 times 1/2 to the 0 is 4. Okay. The common ratio is 1/2. We can see that from what we're multiplying by. And then I need the first term, I need the ratio, and I need the number of terms. So since and I need the number of terms, not the last term. So since the number here starts at 0, and this ends at 20, that's actually 21 terms. If I count from 0, that's 21 terms. So a sub 1 we figured out was 4. 1 minus 1/2, because that's my ratio, to the 21 over 1 minus 1/2. Work that out, and you get 8. Okay. In an example like this, this is simple. I would just add these together on a calculator, be done with it. And in an example like this, I'm going to do it like this one here. Okay, I'm going to plug in 1 because that's where it starts to get my first term. Then I'm going to see that I have 10 terms. I'm going to fill in the formula. My common ratio would be -2. And then I'm going to go from there. Okay. All right, you can also, something that's different about geometric series is you can find the sum of an infinite geometric series by taking your first term and just dividing it by 1 minus r. Okay, so if it's infinite, I can still find the sum. All right, and you also need to be familiar with these words, whether it converges or diverges. It's thought to converge if your number gets closer and closer to a certain number as it gets bigger and bigger. Okay, if it doesn't converge, then it diverges. All right, so you can see here there's a rule: an infinite geometric series with r, absolute value of r greater than or equal to 1. So if your common ratio is 1 or bigger, if you think about the absolute value of it, I mean, think of it in the positive term only. If it's 1 or bigger, it's going to diverge. If it's a fraction, it's going to converge. Okay, so for example, let's go back to what we just saw. I need to go. No, do I go back again? No, I think I'm down here. No, I need to go back again. Okay. All right, so here my ratio is 2. 2 is bigger than 1, so it's going to diverge. Here my ratio is 1/2. 1/2 is less than 1, so it's going to converge. Okay, that's all I have to look at. All right, so here I can just see that I keep multiplying by 1/2. If you can't see that, you can divide this by this and you'll get 1/2. You can divide this by this and you'll get 1/2. So I can see that the ratio is 1/2. 1/2 is less than 1, as they say here, so it converges. Here, my ratio is actually bigger than 1. A lot of people think that every fraction they see is less than 1. This is 5 over 4, which is bigger than 1. In the absolute value, that's positive 5 over 4. Bigger than 1, it diverges. Okay? So there's that. And then we move on to the assignment from there. Okay? That's the basics. You've seen a few examples. I hope this helps. If it doesn't, give me some feedback, and we'll talk about how I could do a better one next time. All right, thanks. Have a good day, guys.